In this lecture, we are going to see two important chapters. First one is size reduction and size separation. So first we will see size reduction. About this size reduction, you can expect around 2 or 3 MCQs from these two chapters. ये दो जो चैप्टर्स है उसमें के 2 या 3 MCQs में भी आ सकते हैं पेपर में, ठीक है, क्योंकि प्रीवियस ईयर के पेपर में भी ऑलरेडी इसके रिगार्डिंग क्वेश्चंस पूछे हैं. So these two chapters are very important. Size reduction, size. Actually, all the chapters from size your pharmaceutical engineering, whatever chapters are there, size reduction, size separation, drying, evaporation, then flow of fluid, fluid transportation, crystallization, evaporation, then material construction, humidification, dehumidification, corrosion, everything is important. They can ask anything from these chapters, so you have to cover it. So we'll see size reduction first of all. Okay, what do you mean by size reduction? Size reduction means deformation of particle into smaller particle, deformation of big particle into smaller particle. So you have your drugs, you have a powder of your drug, so which has a very coarse powder, which is a coarse powder. So you need a fine powder, or you need a gratings, grade, different grades of powder, fine. So for that you have to do size reduction. Okay, so deformation of large material into smaller particles, that is nothing but the size reduction, or breakdown of your large material into small material, that is a size reduction. That is size reduction. It is also known as, remember what are the synonyms for size reduction. It is also known as comminution, diminution, or pulverization. All three are the same terms. Okay, comminution, diminution, and pulverization. Pulverization size reduction is also known as comminution, diminution, and pulverization, remember. And you know that material may be either soft material or hard material. And to decide that the hardness of material, every material has its own hardness, every material has its own toughness. Okay, so to describe that hardness or toughness, depending upon the hardness of surface of material, there is one scale known as a Mohs scale. So Mohs scale is a arbitrary scale for hardness, which has been material has been assigned a hardness number ranging from 0 to 0 to 10 or 0 to 15. Material has given number either 1, 2, 3, 4 up to 10. So depending on that, if material is soft, it is given number 1. If material is very hard, it is given number 10. Likewise, that there is a scale known as a Mohs scale, which will describe the toughness or hardness of particular material. So in relation to hardness, one surface, in relation to hardness of the surface, an arbitrary scale is there known as a Mohs scale. So on which material is assigned a hardness number ranging from 1 to, or it may be range from 1 to 15. So for example, for a soft material, so if material is soft, it will given as number 1. Soft material, they are assigned as a number 1 on the hardness scale. Then 3 to 7 for hard material. So if if material is hard, so they have given number 3 to 7. And if material is very hard, then it is given number 10. If material is very hard, it is given number 10. For example, graphite is a your soft material and diamond is a very hard material. So diamond has a hardness number 10 on Mohs scale. What is the importance of size reduction? What are the, so size reduction is done for, there are different reasons for size reduction: to get a uniformity of content, to get a uniform flow, to get a stability and all that. Okay, so we'll see one by one. There are different reasons for size reduction. So you can read your, if you want to prepare a semester, you might have seen there are different factors affecting on size reduction, different reasons, merits and limits on that. So first one is a size reduction is done for content uniformity. So if you have uniform size of particle of your powder, suppose that you have paracetamol. So if you don't have particular, if you don't have enough uniform size of the particles, then there may be a chance of dose dumping. There may be a chance of dose. There is a dose not. There is an ununiformity of dose. So for uniformity of dose, for uniformity of content in a particular tablet, you need a uniform particle size of the material. That is the saturation for content uniformity. Second, it is also important for your uniform flow of particles. Suppose that you are want to punch, you want to formulate, you want to sorry, you want to formulate. Suppose that you want to formulate a tablet and you have prepared the granules, okay, and the granules are in the hopper. Now the granules must have to flow from hopper to the dye cavity of tablet, so that the tablet will be punched, tablet would be punched over there. And to flow the granules from hopper to the dye cavity, you need a uniform particle size. So suppose it is a too hard, too large particle is there, they will not flow properly. If the particles are too small, they will adhere to the surface. So you need a uniform particle size for proper flow. Okay, so size reduction is done for continued uniformity, uniform flow of particle. Then for effective for effective extraction of drug. Okay, so sorry, for effective extraction of drug. For example, if you want to carry out any extraction, for example, आपको अगर अर्जुना बार्क का एक्सट्रैक्शन करना है, so you want to isolate some androglaphites from arjuna bark, then so you cannot use a bark of 1 kilo 2 kilo for extraction. एक बड़ा वाला bark थोड़ी ले सकते हैं. So for effective extraction you have to do size reduction, and you know that after size reduction, so decrease in the particle size is inversely proportional to your surface area. So less will be the particle size, more will be the surface area of powder or particle that is being exposed to your solvent for extraction. So for effective extraction of crude drug, you need a size reduction. Again, for effective drying and to improve the physical stability, to improve the dissolution rate, so you need a size reduction. So that's why size reduction is done to ensure the uniformity of content, to ensure the uniform flow of powder, for effective extraction of crude drug, effective drying, to improve physical stability, to improve the dissolution rate, etc., etc. To improve the absorption, for example, there are certain drugs, if you use as it is, they are less absorbed. For example, size reduction in case of chloramphenicol and grizopulvine, size reduction of grizopulvine or micronization of grizopulvine has increased the absorption. To improve the rate of absorption, you need a size reduction. Micronization is a process where there is also a size reduction process. So reduction of size in a micron size, in a reduction of particle size in a micron, that is known as a micronization. So micronization of grizopulvine has improved the absorption and bioavailability. So that's why to improve the rate of absorption and to improve the rate of absorption and bioavailability, you need a size reduction again. There is a one scale known as a Mohs scale, MOHS, Mohs scale, which is an arbitrary scale for describing the toughness or hardness of material. So on this scale, material is assigned a number from 1 to 10 or 1 to 15. For example, talc. Talc is a very soft material, so that's why it is given number 1. After that, gypsum. Gypsum is a again soft material. It is given number 2. Like chalate, then chloride, apatite, orthoclase, quartz, topaz, then corundum, corundum. Then after that, diamond. Diamond has a hardness number 10. So diamond is a hard material, very hard material. Okay. After that, this netherite is a very hard material. More will be the number hardness number on the scale. More will be the hardness of material. Nail fingers will have a hardness of 2.5. Your coin or penny, copper coin will have a हार्डनेस ऑफ 3.5. सो योर जो भी आप नाइफ यूज करते हो, चाकू यूज करते हो, उसका हार्डनेस रहता है 5.5. स्टील का जो आपका कील रहता है, किला, उसका भी हार्डनेस रहता है 6.5. ऐसा it is nothing but the Mohs scale describing the hardness of material, not much important. Just remember the Mohs scale is related with the hardness of material. If you remember this, that is enough. Then now disadvantage of size reduction. I am not going to tell you details of disadvantages and advantages. That is not important for our GPAT. So that if you want to read all the disadvantage, advantage, you can read from books. That is for your semester exam. Disadvantage of size reduction. During the size reduction, you use a different meals for size reduction, like cutter meal, hammer meal, ball meal, fluid energy meal, etc. etc. During the milling operation, what happens? There is generation of heat. During milling operation, there is generation of heat, and that heat may affect your product. So drug degradation can be there. Okay, that is one of the disadvantages. Poor mixing due to increased cohesive process. So more will be the size reduction, lesser will be the particle size, and more will be the electrostatic attractive forces. जिसका particle size बहुत ही कम होता है, उसमें ये electrostatic forces active हो जाते हैं और वो cohesive mass बनाते हैं. So poor mixing due to cohesive process. So जो फाइन एकदम एकदम वेरी फाइन पार्टिकल जो होते हैं उसमें कोहेसिव फोर्सेस का ज़्यादा अट्रैक्टिव होते हैं और केक टफ केक बनाते हैं. So it is not easy to mix. So drug degradation, poor mixing due to increased cohesive forces, then contamination during milling and grinding. So how there will be a contamination? Because whatever mills you are using to carry out the combination or diminution or size reduction, so those mills are made up of a iron material, steel, etc., copper material. So sometimes what happen, so iron, copper, they may contaminate your product. Okay, so these are the disadvantages. Next one is the factors affecting on size reduction. So hardness of material, so more will be the harder material, more will be the time required to for size reduction, or more will be the energy required for deformation. Then again, toughness of material, abrasiveness of material, so stickiness of material. So sticky material is not easy to size reduce the size. जो material sticky होता है उसका size reduction करना. Material structure, moisture content. Again, remember over here, moisture content moisture content is also important factor. Size reduction, for optimum size reduction, moisture content should not be more than 10%. Remember this line, write down. So moisture content for size reduction should not be more than 10%. Then softening temperature ratio of feed to the size of product. मतलब कितना मटेरियल साइज रिडक्शन के लिए मिल में डालना है और प्रोडक्ट क्या निकलेगा उसका रेशियो भी. So ratio of feed size to the product size is also important. These are the factors which will affect your size reduction. Now principle or mechanism of or mode of size reduction. So there are different principles like cutting, then impact, then compression, etc., attrition, etc. So we'll see it. The first one is cutting. Cutting means cutting means cutting of your original material to smaller pieces by using sharp blades. That is cutting. What is comminution? Comminution means breakdown of material between breakdown of original material into smaller particle by pressing between two rollers. That is known as a compression, by compression or comminution. So cutting, comminution or compression. You can call it compression also. Comminution and compression. Okay, cutting, compression. Then impact. Impact means heating. Impact means hitting the material by hammers, or hitting the hammers by moving material. Hitting the stationary material by moving hammers. In the both cases, your impact is there. So impact is nothing but the hammers are used to break the lumps and crumbs of the product. Lumps मतलब ढेकड़, ढेकड़ मतलब ये क्या बोलते हैं उसको, ढेकड़ बोलते हैं. Hammers are used to break the lumps and clumps of the product. That is the impact. Attrition means it is a rubbing action between two surface. आपने दो इस ये लिया, दो मान लीजिए कि आपने दो बड़े वाले मिट्टी के पत्थर लिया और उसको एक के साथ में रब किया तो ऑब्वियसली उसका पार्टिकल्स निकलेगा. So that is nothing but the rubbing action, or you can call it as attrition. So attrition means rubbing action between two surface, and it is a surface phenomenon. Then at cutting we have seen cutting, compression, then impact, then attrition, then mechanism of size reduction. Impact. So impact occurs when moving particle strikes against the stationary surface or stationary object. In the same way, particles moving at a high speed collide with each other and produce a small particle. That is nothing but the impact. Okay. For example, see, either this is a particle, moving particle, it will hit on this stationary surface, so it will be broken down. That is the impact. Attrition. Attrition means it involves breaking down of material by rubbing action between two surfaces. ये एक surface है, ये एक surface है, इधर जा रहा है, बीच में जो particles है वो rub हो रहे हैं, और particle जो दो particle है उनके बीच में भी rubbing action होता है. So that is a attrition. We call it attrition. And cutting means breaking down of particle by using sharp blades. Okay, so material is cut by means of sharp blade. It is a useful in combination fibrous and waxy solids. जो भी pharmacognosy के जो drugs होते हैं, so natural and crude drugs, so they will be effectively reduced for the size using cutting. Okay, now next one is compression. This is the mode of material. In this mode, the material is crushed between two rollers by application of pressure. So now this is a one roller, this is a roller, in between material is there. So by compression force, it is being deformed. Okay, that is nothing but the compression. So now different mills used for the size reduction. This table is important. So name of mill, size, mechanism of size reduction, then particle size obtained and feed size. कि पार्टिकल साइज कितना मिलेगा साइज रिडक्शन के बाद में, और इनिशियली आप कौन से साइज का मटेरियल यूज करना है. ओके, देन particular meal, use of particular meal, and which kind of size material is used. Cutter mill used for this material, not used for this material. Okay, so first one is the cutter mill. Cutter mill, the cutting is the principle of size reduction. You will get a 20 to 80 mesh particle size. mesh मतलब sieve, 20 to 80 mesh ये range है, उसमें आपको particle size मिलेगा. And feed size is 0.5 to 0.01 centimeter. It is used mostly for fibrous and crude drug, not used for viable material. Roller mill, second one is a roller mill. So compression is the phenomenon or mechanism for size reduction. You will get again 220 to 200 mesh powder, and it is used for soft material, not used for abrasive material. Okay, याद रखो. Then next one is a hammer mill. The hammer mill hammer will hammer mill will work on a principle of impact. Then you will get a particle size of 40 to 325 mesh. Again, bit size is a 0.5 to 0.01 centimeter. So it is used for almost all kind of drugs and not used for abrasive material. Next one is a ball mill. Ball mill is work on principle attrition as well as impact both. ठीक है, यहाँ पे दोनों मतलब impact plus attrition ये दोनों के ऊपर ball mill work करेगा. This ball mill will act on a principle of attrition plus impact. So you will get a 20 to 100 mesh particle size. So it is used for brittle kind of drug, not used for soft material. Okay. So then next one is a fluid energy mill. So again, attrition and impact both are the mechanism. You will get a particle size of 1 to 30 micron, and you are getting over here smallest particle size is obtained by this fluid energy mill. Remember, smallest particle size is obtained by fluid energy mill. Then it is used for moderately and friable material, not used for sticky and soft material. Again, edge runner mill. Edge runner mill, here crushing and shearing is the mechanism for size reduction. Crushing मतलब क्या कि क्रश जैसे होता है ना कि दो एक स्टेशनरी सरफेस एक मूविंग सरफेस है, दोनों के बीच में क्रश करना है, उसको क्रश करना है मटेरियल को, दैट इज क्रशिंग. एंड शेयरिंग मतलब that is shearing is also a mechanism. Okay? So edge runner mill, crushing and shearing is the, then you will get again a particle size in a range of 20 to 80 micron. Again the pit size is same 0.5 to 0.01, and it is used for all kind of drug, not used for soft and sticky material again. Okay? End runner mill. So both edge runner mill and end runner mill work on a similar principle. Particle size also same, everything is same. Last one is a colloidal mill. Principle for size reduction is a shearing. You will get again here 3 to 75 micron particle size. It is used for all kind of drug, and mostly it is for dry milling and wet milling. यहाँ पे इस टेबल के ऊपर आपको क्वेश्चन कैसे आएंगे, यहाँ पे आपको क्वेश्चन आ सकता है match the following. So find out the correct match. So they will, in one column they will give you this name of mills. In second column they will give you the mechanism involved, and they will ask find match the following respective mill used in the size reduction with their mechanism of size reduction. So like this, or they can also ask the question like match the different mills and their the different mills used for respective product. Cutter mill is used for fibrous material, like this. So they can ask. Then they will also ask you question like this: smallest particle size can be obtained from one of the following mill. So fluid energy mill. Okay, remember. ये दो तीन टाइप के क्वेश्चन यहाँ पे बनते हैं. They can ask the mechanism involved in the size reduction also. So what is the mechanism involved in the fluid energy mill? That is attrition and impact. ठीक है, attrition and impact are the mechanism for ball mill and fluid energy mill. Impact for hammer mill, compression for roller mill, cutting for cutter mill. See, cutting is for cutter mill, roller mill for compression. Then impact is the mechanism for hammer mill. Attrition and impact both are the mechanism for ball mill and fluid energy mill. Then crushing and shearing are for runner mill, edge of end runner mill. And shearing is the size reduction mechanism for colloidal mill. Remember, एक मैकेनिज्म के बारे में क्वेश्चन पूछ सकते हैं, लोवेस्ट पार्टिकल साइज के बारे में क्वेश्चन पूछ सकते हैं, यूज्ड फॉर और नॉट यूज्ड फॉर इसके बारे में भी क्वेश्चन पूछ सकते हैं. नेम्स ऑफ मिल एंड शॉर्ट डिस्क्रिप्शन. यहाँ पे देखो आपके सेमेस्टर में कैसा होता है कि आपको उसका कंस्ट्रक्शन लिखना है, प्रिंसिपल लिखना है, वर्किंग लिखना है, एडवांटेजेस लिखना है, डिसएडवांटेजेस लिखना है. बट दैट डजंट, GPAT में ये सब नहीं पूछेंगे एडवांटेज का, विल गिव यू शॉर्ट डिस्क्रिप्शन only. Okay, so that's why I have summarized this table. Cutter mill and short description, roller mill short description. First one is a cutter mill. What is cutter mill? So size reduction is done by cutting and shearing the feed material with the help of rotating knives and stationary knives. इसमें क्या होगा? दो टाइप के चाकू होंगे, दो टाइप के knives होंगे, rotating and sharp, rotating and stationary. The gap between rotating and stationary knives and opening of sieve determine the particle size of and shape of the product. तो इसके ऊपर क्वेश्चन आ सकता है आपको. Size and shape of the product obtained from cutter mill is decided by the gap between rotating and stationary knives and opening of sieve determine the size and shape of the product. Okay, sieve वहाँ पे कितना कितना मेश का लगा है उसके ऊपर भी पार्टिकल साइज डिपेंड है, या फिर जो गैप है स्टेशनरी नाइव्स में रोटेटिंग नाइव्स में उसके बीच में जो गैप है वो भी डिसाइड करेगा. Rotating knives will rotate at the speed of 200 to 900 rpm. Okay, then next one is the mortar and pestle. So you have used it lot of times. Grinding of material by attrition and pressure between service of mortar and pestle. Then roller mill. So crushing of material between two cylindrical roller of stones or steels and or granite. They are mounted horizontally. That's the roller mill. Hammer mill का क्या है description? Rapidly moving hammers mounted on a powder material which reduces the size of powder material by impact. So these hammers will rotate at 8,000 to 15,000 rpm. That is the hammer mill. What is ball mill? It is also known as pebble mill or tumbling mill or revolving mill. Remember the synonyms of ball mill: pebble mill, tumbling mill, or revolving mill. So rapidly moving ball causes impact and attrition both the powder material that will reduce the size. Next one is a fluid energy mill. So it is also known as jet mill or micronizer or ultra fine grinder. Remember the synonyms. Synonyms are very important. Jet mill, micronizer, or ultra fine grinder. The material feed powder stock is suspended with a high velocity air stream. इसके ऊपर ये भी क्वेश्चन आ सकता है. Feed powder material is suspended in a high velocity of air stream is involved in one of the following mill. ठीक है, तो fluid energy. It will cause impact as well as attrition. Venturi feed cyclone separator or back filters can be used to separate the. Now next one is a colloidal mill. So in case of colloidal mill, one rotating steel disc and one stationary steel disc. ये दो डिस्क होते हैं, एक रोटेटिंग होता है एक स्टेशनरी होता है. जगह पे काटता है तो एक मूव होता है. रोटेटिंग स्टिक जाता आपने देखा होगा पुराने जमाने में घर में ही चक्की रहती थी. So that is a you can correlate the colloidal mill like that. So one rotating steel disc and one stationary steel disc having small clearance or orifice of 0.05 0.75 mm between them. This is description of colloidal mill. Size reduction is done by shearing and grinding. Stationary and this was question in GPAT 20. इसके बारे में GPAT 20 में क्वेश्चन था, ऐसा ही सेम टू सेम लाइन था. So one rotating steel disc and one stationary steel disc having small orifice or opening 0.05 to 0.75 meter mm between them is the description for as a colloidal mill. Edge runner mill, two rollers of the stones or granite having weight in tons mounted on horizontal shaft and they are moves on bed. That is the edge runner mill. End runner mill with like same weight steel plate. यहाँ पे एंड रनर मिल और एज रनर मिल में डिफरेंस एक ही है कि यहाँ पे एज रनर मिल में दोनों भी मूव करते हैं, दोनों भी रोलर्स जो होते हैं माउंटेड ऑन हॉरिजॉन्टल शाफ्ट वो मूव करते हैं. इसमें एक ही मूव करते हैं. हेवी वेट स्टील प्लेट डंबल शाफ्ट मूव्स इन mother surface. Next one is a different types of mill and their variant. This chart is again important. There was a question in GPAT 2019 on this. So we have cutter mill and its variant. जो होता है ना एक गाड़ी है तो उसका वेरिएंट आता है. Cutter mill has a two variant, single runner disc mill and double runner disc mill. Roller mill have a variant like multiple smooth roller or corrugated and then swathed roller. ये दो वेरिएंट होते हैं उसके. Then hammer mill has a variant like Fitzpatrick commuting machine or Pitts mill or stock tornado mill. Okay, ये important. Next one is a ball mill. So ball mill will have a variant like Hardinge mill. And this was question in 2019. But में पूछा था Hardinge mill is a variant of one of the following mill. So Hardinge mill is a variant of ball mill. Again ball mill also have different variant like continuous ball mill, vibrating ball mill, fluid energy mill. So the variant for fluid energy mill is centrifugal impact polarizer. So this remember these variants. These are very important. Book में भी दिया है. Next one is a This one is a diagrammatic representation for cutter mill. So here you have stationary knives and rotating knives. ये जो है ये stationary knives है, rotating knives है यहाँ पे, ठीक? And the gap between stationary and rotating knives will determine the size and shape of your product, ठीक है, जो बनेगा बाद में. Again यहाँ पे एक screen लगा होता है, यहाँ पे 10 mesh लगा होता है. So that will also decide the size shape and of the product. Okay, so the gap between these two and the screen mounted over here will decide the product size. So this one is a colloidal mill. Okay, this one is a colloidal mill. So here it is a stationary stator जो है, that is a stationary plate, and this rotor is a moving plate. There is only small gap over here. See, you can see this gap. So this is known as a orifice between these stationary and rotating surface, stationary or rotating plate. Okay, that will decide the product size. And next one is this is a hammer mill. So these are the hammers they use to rotate at a speed. Okay, and this product to be paid product will be introduced over here, and because of this moving rotor, they will impact on the side. This product will be reduced in the size. Now, clearance between these hammers and stationary surface will decide the product size. कितना प्रोडक्ट का साइज का प्रोडक्ट मिलेगा आपको, ये कौन डिसाइड करेगा कि इन दोनों के बीच में जो गैप है, क्लियरेंस 1/2 इंच लिखा है, क्लियरेंस, दैट विल डिसाइड द प्रोडक्ट साइज. उसके बाद में यहाँ पे स्क्रीन भी लगा होता है यहाँ पे. सी इसमें जो बॉल मिल. Okay, so ball mill, lot of different kind of balls are available, like glass balls, then metal balls, then granite balls, etc. Steel balls, etc. Glass balls are not used because it is too costly. Metal balls are also not used because they will contaminate the. Steel balls are used. Okay, granite balls can be used. This is a ball mill. So this container will rotate. So this will take balls along with that. So ball will be in a motion. This optimum speed of this ball mill is very important. So if you rotate this ball mill at a low speed, at that time these balls will slide on each other, and there will be no size reduction. Metal will be over here and ball will slide on each other. There will be size reduction, but it will be very low. Okay? The efficiency will be very low. In case of high speed, ball will revolve around the container, and there again will be no size reduction. So you have to maintain an optimum speed for this ball mill. So that the ball will go at a particular height and then it will fall on the your material, so that there will be impact as well as attrition. Okay, that is the mechanism. This one is a fluid energy mill, representation of fluid energy mill, where the feed material is introduced into this with high velocity air stream. ठीक है, हवा के साथ में एयर स्ट्रीम के साथ में इसको पास करेंगे. ये मटेरियल जाने के बाद यहाँ पे जो परफोरेशन वगैरह जो है, इसके ऊपर उसका इम्पैक्ट हो जाता है, इम्पैक्ट होता है उसके वॉल में. So whatever wall is of the fluid mill is there. So as the particle are introduced with a high velocity airstream, so it get impacted over here, and there is also attrition between two particles. So attrition and impact are the mechanism. Now again, micropulverizer is also known as micropulverizer is used for sugar, chemical and pharmaceutical and cosmetic industry. Micropulverizer use करते हैं इसमें सब में. Then hammer, crusher and vertical impact pulverizer work on the principle of impact of size reduction. जो hammer crusher होता है या फिर vertical impact pulverizer होता है, they will both work on impact. Hammer mill जैसे. Colloidal mill can be used for sterile product. Remember, colloidal mill जो होता है that can be isolated in a one casing. जो पूरा colloidal mill इसमें ढक सकते हो आप, and that can be used for sterile product. But कोई use नहीं करता है. So fluid energy mill is also known as jet mill or micronizer or ultra fine grinder. Colloidal mill is used for preparation of colloidal dispersion, colloidal suspension, emulsion and ointments. So particularly triple roller mill जो होता है, roller mill भी उसका भी double roller mill होता है, एक triple roller mill होता है. Triple roller mill is used for the size reduction of ointment. Next one is now 10-fold decrease in the particle size will increase, 10-fold decrease in the particle size will 10 will leads to 10 fold increase in surface area. मतलब 10 times particle size अगर डिक्रीज किया तो 10 times surface area उसका increase हो जाएगा. Okay, 10 fold decrease in the particle size will result in the 10 fold increase in the surface area. Now surface area is inversely proportional to the particle size. So as the particle size decreases, surface area will increase. Okay, that is the inversely proportional. Then critical speed of ball mill. इसके ऊपर कभी कोई क्वेश्चन आ सकता है. Critical speed of ball mill. So what is critical speed? So it is given by NC. NC means N means speed. C means critical speed of ball mill is 76.6 divided by square root of D. D is nothing but the diameter of ball. Diameter of mill. So 76.6 divided by square root of D. That will you can calculate the critical speed of mill. Now what is meant by critical speed? The critical speed is the speed which is the highest speed at which size reduction can occur. Above which size reduction cannot occur. इसके आगे स्पीड बढ़ाएंगे तो कोई साइज रिडक्शन नहीं होगा. It is the highest speed of motion. So that is critical speed. Ball mill can be ball mill is operated at a 60 to 85% of the critical speed. इसके 60 to 85% of the critical speed. उसका ही आपको उतना ही उसका स्पीड रखना है, ज़्यादा नहीं करना है, कम नहीं करना है. 60 to 65 of the critical speed. Ball mill is operated at 60 to 85% of the critical speed. Optimum speed for ball mill. You can calculate the optimum speed for ball mill. N is equal to 57 minus 40 log of D. Okay, N is nothing but the number of revolution per minute. D is nothing but the inside diameter of mill in feet. कितना फीट का मिल का इनसाइड डायमीटर है वो D है. ठीक है. ऑप्टिमम स्पीड ऑफ बॉल मिल इज इक्वल टू N इज इक्वल टू 57 minus 40 log of D. ठीक है, याद रखो, इससे आप ऑप्टिमम स्पीड कैलकुलेट कर सकते हो. D is nothing but the inside diameter of ball mill in a feet, 1 feet, 2 feet. ठीक है. I have told you this will happen. The balls will slide on one on each another if you keep a ball mill at low speed. If you keep a ball mill at a optimum speed, then ball will go at a certain height, then they will fall on material. So attrition will be there and impact will be there. If you increase the speed of ball mill, then ball will revolve eccentrically and there will be no side traction. Now for example, a ball mill having 228.6 centimeter. बॉल मिल का साइज अगर 228.6 सेंटीमीटर है, 1.4 सेंटीमीटर जा रहा है उसका, बॉल will have optimum speed of 28 to 125 revolution per minute respectively. This was again a question. A ball mill having, ऐसा ही क्वेश्चन था, ball mill having 228.6 centimeter size and 11.4 centimeter jar, then calculate the critical speed of ball mill. तो उसमें एक ऑप्शन था 28 to 125 rpm respectively. This was question in GPAT. Okay, ये as it is ball एक एग्जांपल देके रखा है बुक्स में आपके, ये एग्जांपल है as it is क्वेश्चन, कुछ भी पूछ सकते हैं. So it is present in the जो आपका CBS बनाने का बुक है उसमें है और मेरे बुक में भी दिया है. Then triple roller mill and colloidal mill is used for grinding and preparation of colloidal suspension, dispersion and emulsion. Triple roller mill जो होता है that is mostly used for your ointments. Colloidal mill is used for making a colloidal solution or colloidal suspension or emulsion. Now, there are two types of grinding. Sometimes grinding is mostly used when there is a involvement of any solvent in the size reduction. So होता है ना कि जैसे आपका colloidal mill है, so in case of colloidal mill weight grinding is done most of the time. So there are two types of grinding. First one is a weight grinding, second one is a dry grinding. Dry grinding में कोई आपका solvent use नहीं करना है आपके material के साथ में. In weight grinding you use water or any other solvent. So weight grinding along with the surfactant you can achieve particle size of 5 micron. In case of weight grinding, surfactant are added to attain the particle size of 5 micron. So surfactant अगर डाल दिया उसमें तो particle size और भी कम होता है. These are the point important points. और theories related to size reduction. इसके related में theories कितनी है? So is a Griffith theory. ये आपको थोड़ा सा मैं बोलता हूँ. आपको इतना याद रखो, Griffith theory is there, then reticulous theory is there, then Kick's theory is there, then Bond's theory is there. I will explain these theories. Theories of size reduction. First one is a Griffith theory. So according to this theory, solid content solid consists of solid means your powder or powder particles or anything solid material that consists of some flaws and microscopic cracks. तो जहाँ से आप वहाँ उसको ब्रेक कर सकते हो, ये theory के अकॉर्डिंगली है कि ग्रिफिथ कहता है कि your particle or material will have certain flaws or certain microscopic cracks. A flaw is any structure which is a weakened that may develop into a crack after certain strain. ठीक है, मतलब certain amount of stress अगर उसको देंगे तो उसमें थोड़ा सा strain आएगा और जहाँ पे भी flaw है वहाँ से वो material टूट जाएगा. Okay, so according to the Griffith theory, all solid contains flaw and microscopic crack. A flaw is a structure which weakens or which may develop into a crack under strain. Okay, the weakest flaw in the particle determines its fracture strength. जो भी आपका वीक फ्लॉ है, मतलब वो वीक एरिया है जहाँ पे ब्रेक हो सकता है, तो वीकेस्ट फ्लॉ इन द पार्टिकल डिटरमाइंस द फ्रैक्चर स्ट्रेंथ. ओके, नाउ according to Griffith theory, the amount what is the theory according to this Griffith theory, the amount of force to be applied it depends on the crack length and the focus of state at the atomic bond of the crack apex. That is the theory. According to Griffith theory, the amount of force to be applied it depends on force apply करना है, क्यों apply करना है, to break down the particle. Okay? So the amount of force to be applied it depends on the crack length. उसका crack length कितना है and focus of stress at atomic bond of the crack apex. Okay, that is nothing but the Griffith theory. Next one is a Reticulous theory. Next one is Reticulous theory. Reticulous theory. So according to Reticulous hypothesis, the energy required for size reduction of unit mass, एक unit mass का size reduction करने के लिए जो energy लगेगी, that energy is directly proportional to the new surface produced after size reduction. Means the energy required for size reduction of unit mass is directly proportional to the new surface produced. That is the Reticulous theory. इसका स्टेटमेंट भी याद रखा या फिर नहीं रखा तो भी चलेगा, ऐसा इंपॉर्टेंट नहीं, लेकिन कभी कभी क्या मालूम कुछ भी पूछते हो. Reticulous theory. Our next one is a Kicks theory. Next one is Bonds theory. So according to Bonds theory, the energy used in the crack propagation is proportional to the new crack length produced. तो एक छोटा क्रैक होता है ना मटेरियल के, तो एनर्जी रिक्वायर्ड फॉर सैचुरेशन is proportional to the new crack length produced, and it states that the energy used for deforming or fracturing the set of particle is equivalent is proportional to the change in the particle dimension. So that is a Bond's theory. Next one is your Kicks theory. Kicks theory. ये यार बाकी नहीं भी याद रखा तो कुछ चलता है. According to Kicks theory, the energy used in deformation for fracturing a set of particles is equivalent to shape is proportional to the ratio of change in the size. ठीक है, ये थ्योरी का जस्ट आपका ये भी रखा याद रखा आपने स्टेटमेंट, दैट इज इनफ. मैकेनिकल बिहेवियर ऑफ सॉलिड अपॉन एप्लीकेशन ऑफ स्ट्रेस. अगर आपने कोई फोर्स अप्लाई किया किसी सॉलिड को तो क्या चेंजेस आते हैं उसमें. सो मैकेनिकल बिहेवियर ऑफ सॉलिड अपॉन एप्लीकेशन ऑफ स्ट्रेस पार्टिकल गेट स्ट्रेन्ड. तो अगर आपने कोई स्ट्रेस या फिर कोई फोर्स अप्लाई किया इसको पार्टिकल्स को, तो वो पार्टिकल को स्ट्रेन आता है. स्ट्रेन इनिशियली द स्ट्रेन इज linear according to the stress. Means if you apply stress, the particle gets strain. If you apply more stress, particle will get more strain at a particular length. Okay, after that the particle will break down. After that particle will be broken down. Okay, the point at which the linearity is gone, that is known as a yield point. Okay, I will explain with the diagram. Suppose that you plot a stress versus strain. ठीक है, स्ट्रेस एक्स एक्सिस पे, स्ट्रेन वाई एक्सिस पे. मतलब यहाँ पे फोर्स लगाया आपने तो मटेरियल के मटेरियल को क्या इम्पैक्ट होगा. सो इनिशियली इफ यू अप्लाई स्ट्रेस, स्ट्रेन विल इंक्रीज linearly strain will increase up to one point. After that, so there will breakdown of your particle, that is known as the point at which this linearity goes known as yield value. Okay, so above yield value plastic deformation is there, and above below this yield value elastic deformation is there. I will explain. So initially आपको स्ट्रेस बढ़ाया आपने तो स्ट्रेन भी बढ़ेगा. अगर मान लीजिए आपने बढ़ाते गए यहाँ तक आए और ओके, और आपने स्ट्रेस रिमूव किया, सो इफ यू रिमूव स्ट्रेस बिलो द yield वैल्यू और yield पॉइंट, सो मटेरियल विल रिगेन इट्स शेप। मतलब आपने थोड़ा स्ट्रेस लगाया, उसको थोड़ा सा फोर्स लगाया और बाद में छोड़ दिया, तो मटेरियल इज अ इलास्टिक, मटेरियल विल गो इलास्टिक डिफॉर्मेशन एंड इट विल चेंज द शेप बट इट विल रिगेन द शेप। ये टूटेगा नहीं, थोड़ा सा टेढ़ा हो जाएगा लेकिन बाद में फिर से सीधा हो जाएगा, लाइक इलास्टिक स्ट्रेन। ओके, सो इफ force of impact does not exceed elastic limit, that is a Hooke's law region, so the material is reversibly deformed and it will return to its original condition upon removal of stress. Elastic limit is known as yield value. Stress energy is deformed particle. Okay, so stress, जो stress energy आपने apply किया था, after breaking the particle, where that energy goes, so that energy will appear in the form of heat in the deformed particle। तो वो एनर्जी हीट के एनर्जी के फॉर्म में इवॉल्व होगा, ठीक है। देन द स्ट्रेस स्ट्रेन कर्व बिकम नॉन लीनियर एट द यील्ड पॉइंट व्हिच मेजर द रेजिस्टेंस फॉर द परमानेंट डिफॉर्मेशन। मतलब यील्ड पॉइंट पे ही ज्यादा सबसे रेजिस्टेंस होता है फॉर द डिफॉर्मेशन। अगर वो यील्ड पॉइंट क्रॉस किया, मतलब आपके फोर्स ने वो यील्ड पॉइंट क्रॉस किया, तो वो मटेरियल ब्रेक डाउन हो जाएगा, ठीक है। Now beyond the yield point, the region represents irreversible plastic deformation. Area under curve is a fracture toughness or modulus of toughness. Fracture of particle can be obtained when the force will exceed elastic limit. Okay, this is the theory of combination. Particle breakdown कैसे होगा, इसका theory है। Now next one is the size separation. Size separation is also known as sieving or shifting or classifying or screening. Yeah, these are the synonym for size separation. Okay. Now this method is the separation of particle according to the size alone. Size separation क्यों करना है आपको? Why there is need of size separation? See, if you have mixture of particle, ठीक है, आपके पास एक ड्रग है, उसका पैरास्टामोल का पाउडर है, वो पाउडर में डिफरेंट शेप के डिफरेंट साइज का उसका पाउडर है, मतलब कोई कोर्स है कोई फाइन पाउडर है। अब मतलब मटेरियल तो एक ही है लेकिन उसमें पाउडर का ग्रेड्स है, फाइन वगैरह, ठीक है। सो it is a non-uniform powder, okay? So it will not establish uniformity of content, it will not establish uniformity of content, then again it will cause a formulation problem, so that's why you have to separate the size, you have to separate the powder according to its size. So coarser particle will be separated, fine particle will be separated, intermediate particle will be separated, okay? So method for separation of particle according to size alone. If material now, if take example of sieve, आपके जो आटा आटा छानने के लिए जो सीव यूज करते हैं उसका एग्जांपल लो। सो आटा ले लो उसमें और शेक करो उसको, कुछ जो फाइन आटा है वो नीचे जाएगा, ऊपर जो भूसा रहेगा, भूसा क्यों, भूसा जो है वो साइज उसका बड़ा होता है। सो इफ मटेरियल दैट रिमेन्स ऑन द गिवन स्क्रीन surface, whatever material is remaining above the screen surface, that is known as oversized or plus material, and whatever material passing through the screen of sieve, that is known as a undersize or minus material. There are different methods for size separation, okay? So like sieving, then sedimentation, etc, etc. Okay, we'll see it up in slide. So there are different grades of powder, and there is a definition of different grade of powder. What do you mean by coarse powder, what do you mean by fine powder, what do you mean by moderately fine powder? इसके ऊपर कभी क्वेश्चन आ जाता है, ठीक है। तो कोर्स पाउडर, मॉडरेटली फाइन, विल सी इट। सो ग्रेड्स ऑफ पाउडर एंड सीव नंबर अलॉन्ग विद द नॉमिनल मेश अपर्चर एज पर आईपी एंड पीपी। तो यूएसपी के अकॉर्डिंगली अलग होता है, आईपी पीपी का अकॉर्डिंगली अलग होता है। सो एज पर आईपी एंड पीपी, कोर्स पाउडर इज डिफाइंड एज द पाउडर the particles of powder must pass through sieve number 10 and at least 40% pass through sieve number 41. Okay, so coarse powder is defined as the particles of the powder that must pass through sieve number 10 and must 40% must pass through sieve number 41, ठीक है। मतलब कोर्स पाउडर क्या होता है कि इसके सभी पार्टिकल 10 नंबर से पास होना चाहिए और 40% पार्टिकल 44 नंबर से पास होना चाहिए, दैट इज अ कोर्स पाउडर। नाउ व्हाट डू यू मीन बाय मॉडरेटली कोर्स पाउडर? So the powder of which all particle must pass through sieve number 2022 and 40% particle must pass through sieve number 60. ये moderately fine क्या होता है? So the powder of which all particle must pass through sieve number 44 and particle of which 40% of particle of which should pass through sieve number 85. Then it is called as a moderately fine powder. Now what is meant by fine powder? So powder of all particles should pass through 85 sieve. That is known as a fine powder. Okay. Then very fine powder. So if particles of powder is able to pass through sieve number 120, then it is known as a very fine powder. Okay. So most of the books में ये सिर्फ ये 5 ग्रेड दिए, लेकिन ये 3 ग्रेड यहाँ पे दूसरे कोई एक आध बुक में मिला है मुझे, तो इसलिए ये भी ऐड किया है मैंने. Okay. So micro fine powder. So if all particles of powder are able to pass through sieve number 350 or 90% of powder particles are able to pass through sieve number 350, then it is known as a microfine. Okay. Then what is meant by superfine powder? So 90% of particle if able to pass through 10 micron sieve, then that is superfine. If 90% particles are able to pass through sieve number 5 micron, that is known as ultra fine powder. Okay. Sometimes they used to ask the question on this. ये very fine, sorry, fine powder के बारे में GPAT में question already पूछा. What do you mean by fine powder? All particle must able to pass through sieve number 85, and 90% of particle must pass through sieve number 85, and 40% pass through sieve number 60, ऐसा कुछ था, और बाकी ऐसे ऑप्शन थे. So correct answer was sieve number 85. So fine powder is nothing but the all particle of powder must pass through sieve number 85. Like coarse powder, all particle must pass through sieve number 10 and 40% particle should pass through sieve number 44. Okay. उसका एक नॉमिनल में सापर्जक भी दिया है यहाँ पे, नॉमिनल में सापर्जक. ठीक है. sieve नंबर 10 का नॉमिनल में सापर्जक होता है 1.7 mm. तो नॉमिनल में सापर्जक क्या होता है मैं बोलता हूँ आपको बाद में, और sieve नंबर का डेफिनेशन भी बोलता हूँ. दिस चार्ट इज इम्पोर्टेंट, इसके ऊपर क्वेश्चन आ सकता है. नेक्स्ट वन इज ग्रेड्स ऑफ पाउडर एज पर यूएसपी. तो ये दैट first slide was grades of powder as per IP and PP. Now it's as per USP. So as per USP coarse powder is defined as the powder which particle must pass through sieve number 1700 micron. sieve जो 1700 micron का sieve है उससे पास होना चाहिए. And 40% particle must pass through a sieve having diameter of 350 mm. Currently coarse powder is defined as the particles of all particles of powder must pass through sieve having nominal mesh of 710 micron, and 40% must pass through nominal mesh of 250. Fine powder is defined as the powder of all particle must pass through 355 micron, then 40% should pass through 180 micron. Likewise, that fine particle is defined as per the USP, that is nothing but the all particles should pass through 180 micron sieve. Okay. Very fine means all particle must pass through 125 sieve. Okay. Ultra fine powder, somehow the pharmacopoeia defines this size fraction as 90% of mass must pass through 5 micron, and no particle should be have diameter greater than 50 micron. That is nothing but the ultra fine powder. We'll see next. The application of various meal screen configuration on perforated screen. जो आपका स्क्रीन होता है, जो सीव होता है, सीव के ऊपर जो स्क्रीन होता है, so what are the different shapes of that screen? So that has been described over here. So perforation, shape of perforation. So the screen, you might have round holes in the that sieve. You might have herringbone type of slots in the sieve. You might have cross slots in the screen. So now these three types of perforations you will normally found on the sieve. ठीक है. आपका जो चालनी होता है उसमें इस टाइप के सब होते हैं. राउंड होल्स दे आर particularly used for fibrous material. Herringbone type of slots, they are mostly used for crystalline as well as amorphous material. Then cross slots are useful for amorphous material and slurries with coarse particle. Okay, it is not much important but you should have. Now ये इसका कमेंट भी दिया है यहाँ पे. राउंड होल्स में क्या प्रॉब्लम आता है? राउंड होल्स यूज टू टेंड्स टू क्लॉग मोर क्विकली. राउंड होल्स जो होते हैं वो जल्दी ही उसका क्लॉगिंग हो जाता है. लोअर होल साइज लिमिटेड. देन herringbone टाइप ऑफ स्लॉट्स में क्या होता है कि स्लाइटली कोर्स पाउडर देन इक्वल डायमीटर राउंड परफोरेशन. देन क्रॉस स्लॉट में क्या होता है कि सम ग्रैन्युल्स साइज एज इक्वल टू द साइज ऑफ राउंड परफोरेशन. तो ये छोड़ो, ये नॉट नॉट मच इम्पोर्टेंट। आपको ये मालूम होना चाहिए कि देयर आर डिफरेंट शेप्स फॉर परफोरेशन ऑफ योर सीव। सीव का जो परफोरेशन होता है उसमें राउंड भी हो सकते हैं, स्लॉट भी हो सकते हैं, क्रॉस स्लॉट भी हो सकते हैं, ठीक है। तो राउंड फाइब्रस मटेरियल के लिए यूज होता है, हेरिंगबोन एमरफस क्रिस्टलाइन मटेरियल के लिए क्रॉस स्लॉट जो होते हैं वो आपके ये आपके एमरफस मटेरियल के लिए होते हैं, ठीक है। यू कैन सी ओवर हियर, सो सीव्स मे लुक लाइक दिस। आपके घर में जो आटा आटा आटे के लिए सीव है वो राउंड रहती है या फिर ये ऐसा वायर्ड रहती है, ठीक है। सो वायर्ड विल बी देयर। So round will be the shape of sieve, then squares, then this rectangle aligned to length, rectangle aligned to the length, rectangle aligned to the width, ऐसे। और क्रॉस स्लॉट मतलब क्या, ये क्रॉस होंगे, ये ऐसा है तो ऊपर से एक आएगा उसको क्रॉस स्लॉट है इन वन टाइम। Now screens may be either now sieves may be either woven wires, जो वायर का बुना बुना हुआ रहेगा वायर्स का, या फिर वहाँ पे बार्स रहेंगे ऐसे बार्स। मोस्टली दिस काइंड ऑफ बार्स आर यूज्ड इन द, अगर आपने वो मणि यंत्र वगैरह देखा होगा तो उसमें रहता है स्टैंडर्ड्स फॉर सीव। सो these sieves must have standard. See, these sieves must be according to the standards. There are different standards for sieves. First one is a Taylor standard. Taylor standard sieve series. Now this Taylor standard is used in the USA. Now next one is a US standard sieves. It is also used in the USA. Next one is a British standard. तो it is for UK. कि ब्रिटिश ने बोला है कि हमारे सीव ऐसे होने चाहिए, इसका नॉमिनल में अपर्चर इतना होना चाहिए, ठीक है। ये सब टेलर ने बोला कि इतना होना चाहिए, उसका टॉलरेंस इतना होना चाहिए। देन जर्मन डीन फॉर जर्मनी एंड यूरोप, जर्मन डीन स्टैंडर्ड फॉर जर्मनी एंड यूरोप। देन इंडियन स्टैंडर्ड सीरीज इंडिया, इंडिया के लिए आईपी स्टैंडर्ड। देन इंटरनेशनल टेस्ट सीरीज WHO वर्ल्ड वाइड। तो ये स्टैंडर्ड है, दे विल कंट्रोल द डायमेंशंस ऑफ सी, डायमेंशंस ऑफ सी। नॉमिनल में अपर्चर कितना होना चाहिए 10 नंबर से का, तो वो कौन डिसाइड करेगा, ये डिसाइड करेगा। इंडिया में कौन डिसाइड करेगा, आईपी स्टैंडर्ड से। तो उसमें टॉलरेंस कितना है, कितना बेयर कर सकते हो। इंपॉर्टेंट पॉइंट्स फ्रॉम दिस चैप्टर, number of sieves definition is important. It was a question in GPAT, I think 9 20 or 18 या 20 में था कुछ तो। number of sieves, this is defined as the number of mesh in the length of 25.4 mm, that is 1 inch. So number of mesh in the 1 inch, that is nothing but the sieve number, कि 1 इंच 1 स्क्वायर इंच में कितना ओपनिंग्स है sieve का, ठीक है। राउंड होगा या फिर कोई सा भी होगा, राउंड होगा या फिर स्क्वायर होगा या फिर स्लॉट होगा। सो नंबर ऑफ meshes इन द लेंथ ऑफ 25.4 mm, that is 1 inch, in each direction parallel to the wire, that is nothing but the sieve number, okay। And amount of powder used while sieving is 35 to 40% of total capacity of sieve। कि मान लीजिए कैपेसिटी sieve का है आपका 1 kg, तो आपको 1 kg पाउडर नहीं लेना है sieve में, so only 30 to 40% of total capacity, so for effective size separation, okay। Now sieve number is this definition is important। sieve number का definition जो है important है, याद रखो। number of mesh in a length of 25.4 mm, that is 1 inch, okay। Now what is meant by mesh, I will explain। different type of sieves like woven wire sieves, then blotting cloth, then closely packed bars in punched plate perforation screen, ऐसे इस टाइप के सीव्स वगैरह होते हैं। पहले अपन ये देख लेते हैं, बाद में ये पॉइंट्स थोड़ा सा इंपॉर्टेंट। सी दिस इज अ योर सीव, ओवन सीव, ओके। सो नाउ दिस इज नोन एज अ वन मेश। ये जो ओपनिंग है ये बीच में का, दैट इज नोन एज अ वन मेश, टू मेश, थ्री मेश, फोर मेश, फाइव मेश। सो नंबर ऑफ मेश पर 1 इंच, नंबर ऑफ मेश इन अ एरिया ऑफ 1 इंच, कितना यहाँ पे 5 है, दैट व्हाई यू कैन कॉल इट 5 नंबर सीव। So number of mesh will be 10 in a 1 inch, then it is known as a 10 number sieve. If number of meshes in the 1 inch area, if it is a 40, it is known as a 40 sieve. Okay, likewise that sediment, and then it was a sieving method. Now next method is a sedimentation method. So sedimentation means the sedimentation method Fluid is a stationary and separation of particle of various size depends on the solely on velocity of particle. यहाँ पे क्या करना है, एक बड़ा सा आपको टैंक लेना है, टैंक में आपको पाउडर डालना है. So powder will have a different size of particles. So according to the size and mass of particle will get downward in the particle will get sediment at a different rate, where particles will go under sedimentation at a different rate. Okay, so here Stokes law is applicable. Stokes law is applicable and Stokes diameter is measured. Okay, remember. Now more will be the size of particle, more will be the mass of particle, so it will move at higher velocity, it will sediment at higher velocity. If particle size is less and mass is less, uh, it will not sediment at a higher, or it will sediment at low velocity, or at low velocity. Okay, so that is sedimentation. Then illustration is also another method. So it is similar to sedimentation method only, but in this technique, the fluid flow in a opposite direction to that of sedimentation movement, so that the gravitational illustration, so that the in gravitational illustrators particles moves vertically downward, while the fluid moves vertically upward. तो इसमें अपोजिट डायरेक्शन में होता है. ये सेडिमेंटेशन में क्या है कि यहाँ पे जो लिक्विड है आपने ये रख दिया, या फिर लिक्विड या फ्लूइड जो भी है वो यूनिडायरेक्शनल है, यहाँ पे अपोजिट डायरेक्शन में फ्लो हो रहा है रोटेशन में, बस उतना ही डिफरेंस है. Stokes diameter is involved in the size separation by sedimentation method. Okay, process involved in the forces or the process involved in the motion in the size separation. कितने टाइप के मोशन होते हैं? एजिटेशन होता है साइज सेपरेशन में. मतलब आपने अगर सीव में पाउडर ले लिया और आपने उसको शेक ही नहीं किया तो कैसे होगा साइज सेपरेशन? ठीक है, सो एजिटेशन इज रिक्वायर्ड, देन गायरेशन इज आल्सो देयर, देन ब्रशिंग, सेंट्रीफ्यूगल फोर्स, that is the forces involved in the motion of size separation. Then sieve shaker machine. Sieve shaker machine is officially in Indian pharmacopoeia. जो sieve shaker machine होता है that is officially in Indian pharmacopoeia. इसके बारे में भी एक बार क्वेश्चन पूछे. One of the following machine is official for size separation in the Indian pharmacopoeia. So that is a sieve shaker machine. Then electromagnetic sieve shaker and sonic shifter are the variant of मैकेनिकल सीव शेकर. सीव शेकर जो होता है उसमें बहुत सारे सीव्स लगे होते हैं. सीव नंबर 10, 40, 60, 80, 85, 100 एंड 120 ऐसे सीव अरेंज किए जाते हैं इन असेंडिंग मैनर, और उसको शेक किया जाता है मैकेनिकली. दैट इज अ मैकेनिकल सीव शेकर व्हिच इज ऑफिशियल इन द इंडियन मार्केट. नाउ उसका वेरिएंट कौन सा है? इलेक्ट्रोमैग्नेटिक सीव शेकर, देन सोनिक शिफ्टर, दे आर द वेरिएंट. इन द यूनाइटेड स्टेट two type of standards are used for sieve, US standard and Taylor standard. इसके बारे में कोई पूछा नहीं आपको, सिर्फ नाम याद रखो. In case of Taylor standard, the ratio of width opening of successive sieve is square root of 2. तो ये क्या है कि width of opening of two successive sieve, ये दो opening होता है मेश का, that is nothing but the square root of 2. The ratio उसका कितना होना चाहिए? Square root of 2. Taylor standard scale is based upon the size of opening 0.0029 inch in a wire. In a wire clothing having 200 openings per linear inch, so you can call it as a 200 mesh. ठीक है, इस साइज का अगर 200 ओपनिंग है एक इंच में, उसको बोलेंगे 200 mesh. So this is again important. Sometimes they can ask you Taylor standard कितना है सीव का, US standard कितना है सीव का. It is again a ratio of 2. So National Bureau of Standard in the general uses the ratio of square root of 2, but it is based upon the opening of 1 mm. यहाँ पे opening कितना है? 0.0029 inch. यहाँ पे कितना है opening? 1 mm. 18 meshes. Then again उसका standard भी दिया है. 10 number sieve का mesh aperture कितना होना चाहिए? Nominal mesh aperture. 10 number sieve should have nominal mesh aperture of 1.7 mm. 44 sieve should have mesh aperture of 355 micron. 60 number sieve, ये सिर्फ मैं पढ़ के बताने से कोई ये भी नहीं है, इम्पोर्टेंट भी नहीं है. ठीक है, उसमें टॉलरेंस मतलब क्या कि नॉमिनल मेश अपर्चर, टू मेंटेन नॉमिनल मेश अपर्चर, यूनिफॉर्म नॉमिनल मेश अपर्चर इज अ वेरी टीडियस टास्क. यूनिफॉर्म नॉमिनल में अपर्चर रखना कठिन है, तो उसमें क्या है कि टॉलरेंस है, मतलब प्लस माइनस थोड़ा बहुत इधर उधर हो गए तो भी चलेगा, लेकिन कितना इधर उधर। तो सो फॉर 10 नंबर सी नॉमिनल में अपर्चर इज 1.7 एंड टॉलरेंस इज 0.06। इसके बारे में एक बार क्वेश्चन पूछा था। Then for 10 number 40 perceive, sorry, number 40 perceive, the nominal mass aperture is a 355 micron and you can tolerate 13 plus minus 13 micron. Okay. For sieve number 60, 250 micron is the nominal mass aperture size. ये nominal mass aperture size क्या होता है कि जो जो ये होता है आपका एक जो स्क्वायर होता है या फिर एक जो राउंड होता है मेश में, तो उसका साइज है, ठीक है। सो 250 माइक्रोन इन अ 60 नंबर सीव, so plus minus 13 again, and in case of 120 sieve, so nominal mass aperture is 125 micron and tolerance is 8.1 mm। यूएस स्टैंडर्ड का सीव होता है, इसमें ये माइक्रोन साइज का है। 2000 माइक्रोन इज नोन एज 10 मेश। देन ऐसा बाकी बाकी कुछ इंपॉर्टेंट नहीं है इसमें, और बाकी ये टेलर स्टैंड होता है। अभी मैं इसको आपको ये लास्ट वाला पोर्ट स्लाइड जो है वो एक इम्पोर्टेंट। Now equipment used for size separation, cyclone separator, centrifugal forces involved in the cyclone separator. So material is separated according to a material is separated solid from fluids. Separation depends on the particle size and the density of particle. So centrifugal force is used in the cyclone separator. Now variant of cyclone separator is known as variant of cyclone separator is known as Doroclone. Then bag filters are used to separate the fine particle from coarse particle. Now this chart is important. Particle size separation by different method. कौन से मेथड से आप कितना पार्टिकल साइज सेपरेट कर सकते हो? ओके, सेपरेशन मेथड मींस जो है, so there are different separation like sieving, then elutriation, then cyclone separation. Okay? So by sieving you can separate the particle size in range of 5 to 10,000 micron. 5 to 10,000 माइक्रोन में पार्टिकल साइज सेपरेट कर सकते हो बाय सीविंग। जैसे सीविंग होता है, माइक्रोस्कोपिक मेथड होता है। सेडिमेंटेशन मेथड से क्या, उसमें दो है, बाय ग्रेविटेशनल फोर्स, बाय यूजिंग ग्रेविटेशनल फोर्स, और बाय यूजिंग सेंट्रीफ्यूगल फोर्स। बाय यूजिंग ग्रेविटेशनल सेडिमेंटेशन यू कैन सेपरेट 5 to 1000 micron in size. You can separate a particle size in the range of 5 to 1000 by using gravitational sedimentation. By using centrifugal sedimentation, you can separate a particle size in a range of 0.1 to 5 micron. Okay, that is the lowest particle size that can be separated. That is nothing but the sedimentation, or by using centrifugal force, centrifugal sedimentation. Now next one is a इलुट्रिएशन। सो इसमें भी दो टाइप होते हैं, वाटर एंड एयर ग्रेविटेशनल इलुट्रिएशन एंड सेंट्रीफ्यूगल इलुट्रिएशन. सो यू कैन सेपरेट particle size in the range of 10 to 500 micron by using water and air gravitational illustration. By using centrifugal illustration, you can separate 0.5 to 50 micron particle size. Using cyclone separator, you can separate particle size in the range of 2 to 50 micron. I will explain here.